Okay, so here we go again. Here's the back. So for number 4, it says a geometric sequence has a first term 0.4. So u1 equals 0.4 and a common ratio of 2. Find the value of n such that s sub n is equal to 26,214. All right. Oops, you can't see anything. I'm very sorry. Okay, so there's that. So the first thing we want to do, we have U1, we have R. Let's just calculate the sum of the first n terms using what we know. So we know that we have 26,214. And we can set that equal to 0.4, which is our first term, times 2, which is our common ratio, to the n power minus 1, all over 2 minus 1. These common ratios of 2 are super nice. Okay, so when we do this, ooh, that was so ugly. Okay. We will have, so we can multiply both sides by 1, not a big deal, divide by 0.4, and we would end up getting that 65,535 was on our left-hand side. That's after dividing by 0.4. Dividing by a number that is smaller than 1 is going to make your number bigger. And then that should be equal to 2 to the n minus 1. And then we can add 1 to both sides. And then that will give us that 65,535 is, 536 because we added 1. Boom, is equal to 2 to the n. Now, you guys should have practiced this exponential and logarithmic stuff. I think you did it one day while I was out, and we've been doing it for warm-ups. Now, to get rid of this like exponential function right here, we would want to take the log of each side with the same base as the exponential function. So we're going to take the log base 2 of 65,536. You also can just convert this into logarithmic form using your formula packet if you forget this part. But I feel like you guys understood this better. And so on the right-hand side, the log base 2 and the 2 to the n cancel, leaving us with just n. And then you can use your calculator to calculate the left-hand side because we don't know how to do the algorithm to get the log base 2. So, and that's fine. We can just use our calculator. To do that, we do alpha window 5, and we'll get a log with a base that we can, let me see if I can zoom in so you can see. And maybe brighten this a little bit. Sorry. Come on. Okay, there you go. Now you can see. So we want to put our base of 2, and then we want to put our 65,536 on the inside of the logarithm. Click enter, and we get a super nice number 16. Okay, and that's our n. All right. Again, if you didn't catch that, to do the logarithm in your calculator, you do alpha window 5. Okay, and it comes up. Anyways, okay, so that's number 4. Let's talk about the marks. There's a total of 6 marks here. You would get at least 1 mark for setting this whole thing up. 1 mark for solving here, 1 mark for solving here. You would definitely get a mark for this answer. So that's a total of 4. We need 6. We'd do a mark for doing your logarithm. And then, let's see. Let's do 2 marks for your answer. That's a lot of work to get all the way to the end. Oh man, I'm doing this very poorly. I'm very sorry. Okay, so let's do 2 marks for your final answer, and then 1 mark for your work all the way through. So 4 marks total for work, 2 marks for your answer, giving us a total of 6 marks. Okay. All right, number 5, the last one. And don't forget, you can obviously pause to take a minute to write stuff down. Okay. So number 5 says 2 students, Anne and Ben, play a game similar to Monopoly. I hate Monopoly. Each time Anne passes go on the board, she receives $15. Each time Ben passes go, he receives 8% of the amount he already has. Both students start with $100. So Anne is going to have an arithmetic sequence or series because she's adding the same difference every single time. Ben will have a geometric series because he is multiplying what he already has by that rate of 8% each time. So it asks how much money will Anne have after her 10th lap. So Anne will have a common, or this is her general term. I'm calling her final amount A sub n for Anne. And it's going to be equal to U1 plus her n minus 1 times 15, which was her common difference. So if we fill in what we know that Anne started with $100. We're doing our 10th lap, so this is going to be 9. 10 minus 1 is 9 times 15. And our final answer here should be 235. So she should have $235. Okay, and you get 1 mark for that answer. Okay, then it says identify the type of sequence represented by Anne's winnings. This is arithmetic. And you get 1 for that answer. Then it says how much money will Ben have after the 10th lap. So this one is asking about Ben's 10th lap. Remember that Ben has a geometric sequence. So we want to do the sum of our first 10 terms. So we put our U1 right here. Then we have 1.08 as our rate to the 10th power minus 1, and then 1.08 minus 1 on the bottom. Okay, so now you might be asking, where did we get this 1.08? It's because we want to take our total 100%. 1 represents 100% of our total, and we want to add 0.08% to that each time. Okay, if we just had 0.08 in there every single time, our amount would go down because 0.08 is smaller than 1. So that's why we have this 1 plus 0.08 right here. And then when we solve this, I'll spare you the algebra.